Welcome to section 3.1 and the start of chapter 3. If you're in one of my in-person classes, sorry about the sudden change of plans today. I had short notice myself. Um, Everything's okay with me if you're curious. Nothing to worry about there. All right, so in chapter 3, our goal is to be able to analytically describe structure of a data set or to talk about the distribution of a data set. So our goal here in this first section, section 3.1, is to come up with a way that we can describe where the center of our data set is, or the middle of our data. Okay, so we're going to do that through three measures, and we want to be able to calculate. They're not difficult calculations, so don't worry about that. We have the mean, median, and mode. You've probably heard of those before. And then we're going to talk about when it's most appropriate to use each one of these measures of center. Okay? So the first measure of center we're going to look at is the mean. And you're probably familiar with this just by the name of average. Usually when you talk about finding the average of something, this is what we're talking about, this type of mean here. Mean is a little bit more of a technical name, and there are different ways you can calculate averages or means. So this one specifically is called the arithmetic mean or the arithmetic mean. Okay, and it's the one you're familiar with. Okay, so if you look at the formula, it might look a little scary. It's probably just because the notation's not super familiar. But all this says, okay, first of all, our symbol, if we're talking about the mean of some sample data, then our symbol is this X with a bar over the top of it, and you just read it X bar. Okay, so that's pretty easy to remember. Okay, so X bar is our sample mean. And all we do to calculate this is just what you're familiar with probably. We just take and add each X value together, okay, however many we have. We add them all up. And then at the end, we divide by how many of those we had. Okay, so we just divide by the number of data values in our sample. And the second part of the formula, it says the same thing, but you'll notice it's using this notation. Okay, that thing is the Greek letter sigma. Okay, and all that means as a notation is that we're going to find the sum, or that we're going to add a bunch of things together. Okay, so this thing is just telling us that we're going to add up all of our X values. And the little I down there just means that we take x1, x2, x3, x4. So that's the ith data value. Okay? So we just add up all the X values, all the data values, and then we divide it by how many we have. Okay? Remember, we have to make a distinction if we're working with sample data or population data. So we have another formula slide here if we're dealing with a mean of a population. Okay? We're using all the data values in the whole population. The only difference here, well, a couple of small differences, but the big difference here is that our symbol we use, okay, is this Greek letter. Okay? And this Greek letter here, there's a couple of ways you can say it. It's the Greek letter mu. Okay, so you can say mu, or you can say it's the Greek letter mu. Either one of those is fine, so just decide if you want to sound like a cow or if you want to sound like a cat when you say it. Okay? Either one of those is okay though. And it looks like when I hand draw mine, looks like this. So it's kind of like a U. It has that long tail at the beginning. That is the Greek version of the letter we call M, okay, for mean. So we get this Greek mu. I say mu. That's what I typically say. Okay. Again, on the formula, we just add up all the data values and divide by how many we have. But here you'll notice that the number we're using on the bottom is an uppercase N this time. All that represents is that we're dealing with population values. So we have an uppercase N to represent the size of a population. But then on our other slide, we had a lowercase n to represent the size of a sample. Okay? So that's going to be a trend here. Okay, Greek letters usually tell us that they're describing populations, and lowercase letters usually tell us they're describing a sample. Okay? Or we can have uppercase letters for a population like with the N here. Okay? That's the mean, so let's do one. Okay? I have faith in you that you can do this calculation, but let's do it anyway, just for the sake of completeness. Okay, so here it says students were surveyed to find out the number of hours they sleep per night during the semester. Here's a sample of their self-reported responses. So since this is a sample, well, sorry about that. Since this is a sample, we will call this mean x bar. That's a sample mean. Then to calculate this, we add up all the data values. So 5 plus 6 plus 8 plus 10 plus 4 plus 6 plus 9. And then we divide by how many data values we have. If you count those, we have 7 data values, or you could say our sample size is 7. Okay, and if you add those numbers on the top, you'll get 48. Okay. So we could say our mean is 48 over 7, but that's a really weird way to talk about that number. If someone asked you how many hours of sleep you got last night, it would be really weird if you told them 48 over 7. Okay? So usually fractions are not going to be very helpful depending on the context. So then what we could think about is changing our number to a decimal. And that's usually more typical. So then we run into another question. On my calculator, I get 6.8, 5, 7, 1, on and on and on. Okay, so how do we decide how many decimal places to round to? Okay. Well, we're going to have a standard rounding rule when we're dealing with means. And our standard rounding rule is that we want to round to one more decimal place than our data values had. So here our data values were whole numbers. And they did not have any decimal places. So we're going to round to one decimal place. And I'll use this little squiggly equal sign to let you know anytime I have rounded. So here our one decimal place is 8. Our next digit is a 5. So that means we will round that up to 6.9 hours. That would be our mean here. Okay, so one more decimal place than the data values had. Okay, that is our mean. Okay. All right, let's look at another way we can use this mean formula. Okay, sorry about that. Sometimes I accidentally zoom instead of swiping. Okay. Let's look at this problem. It says Rutherford downloaded 5 new songs from the internet. He knows that on average, the mean, the songs cost $1.23. If 4 of the songs cost $1.29 each, what was the price of the 5th song he downloaded? Okay. Well, if you look at our formula for mean, it tells us that the mean equals, add all the data values up, and then divide by how many we had. So here, this problem gives us the mean. It says the mean was $1.23. That's going to go on one side of the equal sign. And then the way we would calculate that, how would we do that? We know 4 of the songs were $1.29, so that would be $1.29 plus $1.29 plus $1.29 plus $1.29. And then it's asking us what's the price of the 5th song. So we don't know the price of the last song, so come up with some type of variable to use in place of the last song. So we'll just go generic, a typical variable in math class when we use x. You can use a different variable if you prefer. Okay. And then we would divide by how many data values we had. Here we've got 5 songs. Okay. We'll divide by 5. And now we have a little bit of an algebra equation. We won't have a lot of these. We have to work in stats class, but this one's not too bad. So if we work out the top here, that's $1.29 times 4, or you could add it 4 times, either way. So we'll have $1.23 equals $5.16. That's what we get when we add those 4 songs plus x divided by 5. Okay. So you remember algebra class, and the next thing we would do is we would multiply both sides by 5 to to get rid of that division by 5 there. So if we do $1.23 times 5, that tells us we're going to get $6.15 on the left. I'm going to go to a new slide here. $6.15 on the left. And when we, let me get a different color here. When we're multiplying both sides by 5, that's what we're doing. When we do that on the right side, our 5's cancel. And so that will leave us with $5.16 plus X on this other side. We want to get X by itself. So we subtract $5.16 from both sides. On the right side, those cancel. Then we have $6.15 minus $5.16. 615 minus 516. We get that X is 0.99, or that our fifth song cost 99 cents. So if we know the mean, we can figure out our missing data value. That's the idea there. Okay. All right, the next thing we want to talk about is this idea of a weighted mean. You have dealt with these before also, probably. Lots of times when you're taking a class, like homework will be some percentage of the grade, test will be some percentage of the grade. And when those percentages are different, we get what we call a weighted mean. So the idea there is that not each data value is as important as the other. So maybe one data value is more important, like maybe the final exam is more important. So then it would carry more weight or have more relative importance. Okay. We look at the formula here. Again, it may look a little scary because we've got this sigma notation in here, but remember all that means is we're going to add. Okay. So here what this is telling us is when we have a weighted mean, we have to have weights given to us. So those are W's, okay, and the X's are just the data values. So we take each data value, multiply it by its weight, and then we're going to add all of those up. Okay, so we're going to do that for all the data values. And then on the bottom, all we do is we add up all the weights, and then we do what we got on the top divided by what we get on the bottom. Okay. Not as bad as it may sound. Let's look at an example. Okay. One says the syllabus in Walter's U.S. History class states that the final grade is determined by test with a weight of 40%, homework at 20%, and quizzes at 10%, the final exam at 30%. We've got students in Walter's class that want to calculate their final grades. I think I actually took Virginia out of here, so we're only doing Walter. It says below are their average grades in each of the categories for the test, homework, and quizzes, and they've guessed at what they might score on their final exam. Okay, sounds like something students do there. Okay. So here we go, and I'm going to write down the weights. It says test were 40%, homework was 20%, quizzes were 10%, and final exam is 30%. That way we don't have to flip back. Okay. So if these are his final scores, we want to calculate his grade, which would be a weighted mean. So here we're going to take each score, each grade, those are our data values, multiply it by its weight, and then we will divide by the total weight. Okay. So here our first data value is 83. It has a weight of 40%. If we change 40% to a decimal, that's 0.4 or 0.40. Plus homework, we had a 98 with a weight of 20% or 0.2. Plus quizzes, we had a 90 with a weight of 10% or 0.1. And then 87 on the finals, what he's guessing, with a weight of 0.3. Almost ran out of room here, sorry. And then we would divide by all the weight, so 0.4 plus 0.2 plus 0.1 plus plus 0.3. Okay, so let's see what we get on the top. 83 times 0.4 plus 98 times 0.2 plus 90 times 0.1 plus 87 times 0.3. And on the top here, we get 87.9. And on the bottom, we have 0.4 plus 0.2 plus 0.1 plus 0.3. We get 1. So this one's kind of boring because the sum of our weights is 100%. So here, Walter's final grade is 87.9. Okay. So formula may look a little scary, but it's not too bad. Okay. And maybe I did leave Virginia in here, but we'll skip her anyway. Okay, same idea. Okay. All right, our next measure of center is called the median. Okay. And the median is what we would say is the middle data value. Okay. So first, it's very important that we put the data in order, or make an ordered array. You want to use the fancier terminology there. Okay. Then we can say the median is the middle value in the data set. Okay. We've got two situations, and you can pause and read them here if you want to, but we're going to do one of each. We can either start with an odd number or an even number of data values. Like I said, we're going to do one of each. With the idea, we just want the middle number in the data set. Okay. So pause and read this if you want to. We're going to go on to examples here. So here we're given the numbers of absences for samples of students in two different classes. We want to find the median for each sample. Okay. Step one, very important. This is the most common mistake I see, is people forget to put the data in order. So we've got to put our data in order. I'm going to do mine from smallest to biggest. Okay. So I've got 2, 3, 4. I'm going to mark them out as I go. 2, 3, 4, 6, 7, 8, 9. Okay. And got them all there. All right, then we want the middle value. Okay, here you may be able to just look at it and see that 6 is the number in the middle there. If you have a larger data list, then you may want to go back and forth, cross the numbers out on both sides till you get to the middle. Okay, that's fine. But here our median would be 6. Okay, so this is the situation where we start off with an odd number of data values. In that case, we have exactly one value in the middle, and that number is our median. Okay. All right, let's look at data set B here. Again, we want to put them in order. So let's see, I see 1, 4, 5, 7, 8, 8, 9, 9. 8, 8, 9. Okay, got them all there. Now, if we, if we cross values off, what have I done to the screen here? One moment, let me get this technical issue fixed. Okay, be glad you didn't have to sit through that. I froze the whole thing up. All right, so let's pick back up where we were. We're marking data values off from each end. Okay. Look what happens on this one. When we get to the middle, we've got 2 middle numbers. And we don't have one exactly in the middle. It's kind of split between 2 values. So in that case, this is when we start with an even number of data values. This happens. In that case, what we're going to do is we're going to take our 2 middle numbers, add them up, and divide by 2. What we get will be our median. So on this one, our median would be 7.5. So either you have one number exactly in the middle, that's the median, or you have 2 middle numbers, add them up and divide by 2. That would be the median. Okay? All right, so that's all there is to the median. Our last measure of center, okay, that's called the mode. Okay, our definition says it's the value in the data set that occurs the most frequently. And the mode occurs the most. You may have heard that before. Then this tells us if the data values only occur once or an equal number of times, we say there is no mode. Okay. Then you can have more than one mode. Okay. So if you have one mode, you say it's unimodal. If you have two mode, you say it's bimodal. Or if you have more than that, you can say it's multimodal. Okay. These can be a little trickier than you may have seen before, but I'll give you the information you need to not get tricked. Okay, so let's look at a few. All right, we got the number of phone calls received each hour during business hours for 4 different companies. We want to find the mode. Okay. So pause these and look at them if you need to, if you want to try and get them first. And here, see we've got 7 on this one 3 times. Okay, so our mode would be 7. And since we have one mode, we would call that unimodal. Know that I'm not too interested as the teacher in asking you if it's unimodal, bimodal, or those types of questions, because if you write down one number, I know you know it has one mode. If you give me 2 numbers, I know you think it's bimodal, so not that big a deal to me. All right, what about data set B? Okay, if you look at this one, all the data values occur an equal number of times, right? They're all in there once. So if you go back to the definition, this one has no mode. Okay, looking at data set C, again, pause it if you want to figure it out for yourself first. Okay. What I'm seeing is that 2 is on here twice, and 7 is on here twice. That's more than the other data values. So here I would say our modes are 2 and 7. Since we have 2, that would be bimodal. Okay. And what about D? I suggest pausing and thinking about this one for a second. It can be a little tricky. So here, if you look, you got 2 2s, 2 3s, 2 4s, 2 5s. So this one, for some reason, it's a psychological thing, I think. It's tempting to say it's multimodal, and that we have 4 modes. But if you go back to the definition, that's not true. This one would be no mode. Because our definition says if all the data values occur an equal number of times, here they all occur twice. So this one is no mode. Okay? So the little trick I'll give you to figure out if it's multimodal or if there's no mode, okay, is that in order to have a mode, you have to have some data value that is not part of the mode. Okay? So on this last one, if we modified it just a little bit, we put a 6 out here, then our modes, we would have 4 modes. We would have 2, 3, 4, and 5. The reason why those would be modes is because we also have a 6 that would not be part of the mode. Okay? But if you're thinking that every data value is going to be in the mode, then that means that we have no mode. I will not try and trick you on those on the test. I will give you one that's pretty straightforward. And so don't worry about that. But that information is there. You have to have something that's not part of the mode in order to have a mode. Okay. So we have our 3 measures of center. So let's look at the data set and calculate all 3. Okay. So here's a data set. We've got the list of ages. People decided to actually retire. So that means that they stopped working for pay. We want to calculate the mean, median, and mode of this data set. Okay. So I'm going to copy these over to the next slide for us, and then I'll be right back. Okay, one moment, please. Okay, so as I copied them over, I went ahead and put them in order for us. We know we need that for finding the median. It can also help us finding the mode. So here first, we want the mean. In order to find the mean, we add our data values up, divide by how many we have. 42 plus 77 plus 78 plus 79 plus 80 plus 80 plus 82 plus 84. We'll give it 602. And then if you count, we have 8 data values. We're going to divide by 8. Okay, on my calculator, that gives me 75.25. But remember our rounding rule, we want to leave one more decimal place than our original data values had. So I'm going to round to one decimal place to 75.3. That 2 will round up to a 3. So there's the mean. Okay. The median, we've already got our data in order. So we just need to try to find the middle number. Okay, so if we mark values off on each end, you may have noticed when we said we had 8 data values, but we have 2 middle numbers here. So we take our 2 middle numbers, 79 and 80, add those together, divide by 2. So here our median will be 79.5. Then lastly, we want the mode. Here, pretty easy to see, 80 is on there twice. That's more than any other data value, so our mode is 80. Those are the calculations, but now if you take a second and actually think about what we're doing, we said we're trying to come up with where the center of our data set is. But here, we've got these 3, we called them measures of center, and they're all 3 different. So why is that? If you look, the median and the mode are pretty close to each other, and then the mean is a little farther away. Look back at our data set. Do you see any data values in there that look like they might quite not fit in with the rest? The one that's catching my eye is this 42. And we could potentially call that data value an outlier. So if you notice, that outlier is lower than the rest of the data values, and our mean is smaller or lower than the median or the mode. Okay, so this is one kind of potential pitfall of using the mean. Here's a dot plot of our data, as well as the mean, median, and mode plotted on there. Okay, so if you look, the mode and the median, they're here pretty close, but the mean is pulled off over this direction. And that just so happens to be the side that the outlier in our data set is on. And so that's something we have to look out for. If we have any outliers in our data, they will influence the mean, and that will pull the mean toward those outliers. Okay? And the median and the mode, they don't really worry about outliers. Okay, so that's one thing we have to look out for. In general, the reason why we have 3 measures of center is unfortunately it's not one size fits all. Depending on the type of data we are dealing with and whether or not we expect to have outliers in our data set, that determines which measure of center is going to be the most meaningful for us, or you could maybe say the most accurate, okay, as far as the middle of our data set. So we've got some rules, okay, on which measure of center is best to use when. And so here's our list. Okay. So for qualitative data, we use the mode. That one's pretty straightforward. Okay. The reason why we use the mode is because, remember, qualitative data is when we just have labels or names. And if you just have labels or names, you cannot add them up and divide to figure out the mean, so you can't use the mean there. And if our qualitative data is at the nominal level, we can't even put it in order. If we can't put it in order, we can't find the median. So really the only one that works always with qualitative data is the mode. Okay. Next, for quantitative data, the idea is that we want our preferred measure would be to use the mean. Okay. So that's what we want to do. We want to use the mean. Okay. But remember the problem that we have with those outliers. So we use the mean unless we have outliers, because outliers will mess the mean up. Okay. And then finally, we have quantitative data, and we do have outliers. Then we use the median, okay, because the median is unaffected by those outliers. Okay? So let's think about a few examples here. Okay? Figure out which one we would want to use. Okay, so here we've got these data sets. We want to figure out which measure of center would be the best, the most meaningful. Okay, part A, we have t-shirt sizes like small, medium, large, extra large. So there, that would be qualitative data. They're labels. So there we would use, sorry about that, there we would use the mode because our data is qualitative. On B, we have salaries for a professional team of baseball players. On this one, salary would be quantitative. So then we have to think about, would we expect there to be outliers in our data? So the idea here is that on a professional sports team, sometimes you have star players and they make way more money than anybody else on the rest of the team. So in that case, their salary would be an outlier. So here we have quantitative data and we have potential for outliers. So in that case, we shouldn't use the mean because the mean will be messed up by those outliers. So instead, we should use the median. On C, we have prices of homes in a subdivision of similar homes. So price, again, would be quantitative. So we have to think about, would we have outliers here? The thing to think about here is they're all in the same general location, they're all in the same subdivision, and all the homes are similar. So we don't expect one of the homes to be worth way more money than the rest of the homes. They're all similar in the same location. So here we have quantitative data, and we would not expect outliers. So in that case, we are safe to use the mean. Okay. On D, we have professor rankings from student evaluations on a scale of best, average, and worst. And that is qualitative data there. So our best measure of center would be the mode. Almost finished here. This last little thing we want to talk about is what these three measures of center look like on a graph. What parts of the graph represent these three measures of center? So here's our little rule slide. Here it says the mode is the highest peak on the graph. That's where we have the most data values. So that's going to be the tallest peak on the graph is the mode. Is the median divides the area in half. The median sometimes is difficult to see, okay? Especially if we have a skewed distribution one way or the other. It's a little tricky to tell exactly where the median would be. And in order to determine it exactly, you would have to use calculus. Some of you may, if you've taken calculus in high school, you may remember doing integrals to find area under a curve. And we're not interested in that. So what I do is I save the median for last. And then number 3, it says the mean. We've already talked about this. The mean is going to be pulled toward any outliers we have on our graph. Okay. So let's look at one. Okay. Look at this graph. First of all, think about what we would call the general shape. This one we have a skinny tail over on the right side, so this would be skewed to the right, or skewed right. And the reason why we have this skinny tail on the right is over here on the right side somewhere we have at least one outlier. So if we go back to our definitions, we want to figure out the mean, median, and mode, which letter those would be. Okay. So I'll start with the mode. It's the easiest one to pick out. The mode's the tallest point on the graph. That's right here. So the mode would be A. Then I skip the median because it's difficult to see sometimes, especially on a skewed curve like this. And then I go for the mean. Okay? The mean is going to be the closest one toward any outliers we have. So here are our outliers on the right side. We have a skinny tail on the right. So the one that's pulled furthest that way would be C, the mean. And then I know B is the median because that's the one that's left. Okay? And maybe to your eye, it's easy to see that that divides the area under this curve in half. But to me, it's not real easy to see sometimes. Okay? All right, one last thing. What if we have a perfectly symmetrical distribution? So right down the middle. So sometimes you'll have one of these in Hawks, and it'll have like A, B, and then C. And say find the mean, median, and mode. Well, let's think about that. Remember, we're dealing with a perfectly symmetrical distribution this time. Okay. So the mode, again, that's going to be the tallest peak, so that's B. The mean is going to be pulled toward any outliers. Remember, if we're perfectly symmetrical, that means we don't have outliers on either side. So instead of being pulled either way, it's going to be right in the middle, so the mean would be B also. And then again, we said our curve here is perfectly symmetrical. So the line that divides the area in half, since we're perfectly symmetrical, is going to be the line right down the middle, B. So if you have a perfectly symmetrical distribution, all three of these numbers will be exactly the same. Okay, hope that helps. For my in-class students, I will see you in class on Thursday. Let me know if you have any questions.